Assalamu alaikum.
Walaikum assalam, sir.
Yes, any doubt from last class? I think we have derived energy, that is kinetic energy, potential energy, and total energy. It was the last
Yes, sir.
topic?
Yes,
Okay.
sir.
Now, we have to plot variation of kinetic energy, potential energy, and total energy with respect to displacement or time. So let me define you how to plot. So next is graph or variation of kinetic energy and potential energy. In last class, I defined you potential energy. It was half m omega square y square. If you put y is equals to a times sine omega, so it would be half m omega square a square sine square omega t. So this is sine or sine dependent function for which if you put t is equals to 0, so it will be 0 at origin. It means this will be potential energy curve. Similarly, kinetic energy will be half m velocity square. So it will be half m, velocity is omega times of a cos omega t. So it will be cos square omega t. Kinetic energy is cost dependent function. So if you put t is equals to 0, it will be maximum at origin. So graph will be this part. Now, if you add these two terms to get total energy, kinetic energy plus potential energy, you will get half m omega square a square bracket sine square theta plus cos square theta equal to 1. So you'll get this part. And since this is constant, it will be independent of time or frequency. So this will be graph of total energy. Now we may define some term related to this graph. This is position of extreme plus a and also minus a. This is mean position, that is 0. This is one of the point of intersection. So at this point, potential energy and kinetic energy will be equal to each other. So if you draw horizontal line, it means kinetic energy equals to potential energy is equals to total energy by 2. I defined in last class about this one, at which displacement, kinetic energy, and potential energy will be equal. So it was A by root 2 towards positive side, and also A by root 2 towards negative side. Hamza, any doubt?
No, sir.
Next question will be on the basis of time period or frequency related to these different terms. Displacement, velocity, acceleration, kinetic energy, potential energy, and total energy. This is time period, and this is frequency. Time period T, frequency F. So velocity will have same time period and same frequency, and also for acceleration. But in case of kinetic energy, its time period will be just half of time period of actual wave, and frequency will be twice of that of original wave. Similarly, in case of potential energy, but in case of total energy, which is constant, so time period will be infinite and frequency will be zero. So this is the relation between time period and frequency related to these different terms related to SHM. Khalid, any doubt?
No, sir.
So this is relation between time period and frequency. Just write it down. Just 1 minute, I'm coming. Okay, you all have done up to this part?
Yes, sir.
Okay. Now let me define a question related to this one. A particle of mass 400 gram is oscillating as y is equals to 0.05 sine pi times t. Find potential energy at 1/6 of a second, frequency of oscillating, kinetic energy, total energy. Let me define you how to solve. First, we have mass of body, 400 gram. From this equation, this is called amplitude and coefficient of t is called omega. So first we may write mass of body is 0.4 kg. Amplitude we have 0.05 meter and angular velocity is pi. Then if you have to calculate potential energy, it will be half m omega square y square. We have mass, we have omegas. First, we have to calculate y at this particular time, 1/6 of a second. So in this above expression, put t is equals to 1/6 and just simplify it, you'll get y. And on putting this y in this expression, you'll get potential energy. Next, we have to calculate frequency of oscillating kinetic energy. So we have omega. So from this part, we may find frequency of source, that is displacement. Now using this relation, since frequency of oscillating kinetic energy will be twice of frequency of oscillating wave, so you'll get this part. Next, in total energy, it will be just half m omega squared a squared. We have mass of body, we have omega, and we have amplitude. Just put all the values and try to simplify. Hamza, you got any answer? First, calculate displacement. According to the equation 0.05 sine pi times t. Put t is equals to 1 by 6 and simplify it. Khalid, you got any answer?
Yes, sir, still calculating.
Okay. Just see if you put t is equals to 1 by 6 in this part, 0.05 sine 1 by 6 into pi, so it will become pi by 6. Pi by 6 is nothing but 30 degree, and sine of 30 degree will be 1 by 2, so it will become 0.025 meter. Now put in this part, we have mass 0.4 omega pi square and y 0.025 square. So you may write it as 25 into 10 to the power minus 3 square. So 0.4 divided by 2, it will be 0.2. Pi square is taken as 10, and 25 square, it will be 625 into 10 to the power minus 3 square, it will be minus 6. So 625 multiplied by 0.2, it will be 1250 into 10 to the power minus 6, or you may write it as 1.25 into 10 to the power minus 3 joule. Hiba, any doubt?
No, sir.
Try to solve last part, that is total energy. Hamza, just tell me how to calculate frequency. You may write omega is equals to 2 pi f. And in this part, omega we have pi. So pi and pi will cancel out. So frequency will be 1 by 2 or 0.5 hertz. So we have to calculate frequency of oscillating kinetic energy. So for kinetic energy, frequency will be twice of that of oscillating wave. So it will be 1 hertz. Hamza, is it clear?
Yes, sir.
Now in last part, we have to calculate total energy. So it is half mass 0.4 omega pi square, and amplitude we have 0.05, or you may write it as 5 into 10 to the power minus 2 squared. So it will become 0.2. Pi square is 10 and 5 square is 25 into 10 to the power minus 4. 25 into 2, 50 into 10 to the power minus 4, or you may write it as 5 into 10 to the power minus 3 joule. Salman, any doubt?
No, sir.
Okay. Hiba, done?
Yes, sir.
Okay. So this is all about this entire part, that is energy. Next, we have to calculate time period for different oscillating body. Calculation of time period. First, suppose if we have spring mass system, so this is its initial position, which is called mean position. So first, whenever you have to calculate time period of any oscillating body, first try to displace this particular object from its mean position towards any direction, towards left or towards right. So if you displaced it towards right, by this amount, x. So on displacing it by some amount x towards right, a restoring force will get developed into it towards left. So first, we have to calculate a restoring force related to this displacement. So restoring force will be directly proportional to x, but we have restoring force and displacement in opposite direction. So there will be negative sign with it. Now, if you replace this proportionality sign by any constant term, it will be minus of k times of x. This k is called spring or force constant. Further, we may write this force as mass times acceleration is equals to minus of kx. So acceleration is minus of k by m times x. You may write this acceleration as 2 time differentiation of displacement with respect to time. Move this minus k by m x to left side. So you'll get k divided by m times x is equals to 0. So this will be general differential equation of SHM or similar expression like this. So coefficient of x or coefficient of displacement will be nothing but omega square according to actual equation. It was differentiation of y with respect to time plus omega square y is equals to 0. So on comparing these two equations, you will say omega square will be equal to k by m. Is it clear? Hamza, is it clear?
Yes, sir.
So on comparing, we can say omega square is equals to k by m, or simply k is equals to m times omega square. That's why I've written in potential energy k is equals to m times omega square from this part. Now further, we have to calculate time period from this part. So omega is equals to root under k by m. Omega is nothing but 2 pi by t. So if you have to calculate time period, so it will be just 2 pi root under m by k. Now from this entire part, first try to calculate the restoring force for any different oscillating body. So expression of force, or in expression of force, the coefficient of displacement will be k. So if you get k from this part, just put in this part, you'll get time period of oscillating that body. Khalid, any doubt?
No, sir.
Okay, just write it down. Hamza, done? Okay. Now let me give you a question related to this part. Oscillating a rod in liquid. Suppose a cylindrical rod is initially placed like this. So if you compress it slightly downward by this amount, let's say by Y amount. So a pressure will exert on it due to this much column of liquid. And using that concept, we may find a restoring force act on it. So pressure due to column of liquid, it was rho g h. So force or restoring force related to this part will be pressure times area of cross section. Since this is restoring in nature, so there will be negative sign with it. Now just substitute the value of P, so you will get rho g y times A. Khalid, just tell me in this particular expression, which is variable, rho g y or A?
Sorry, sir, could you repeat?
Which of the term in this expression is variable?
Sir, why?
Good.
Oh, G. Why only? Yeah.
Rho is density of liquid, so it will be constant. G is gravity, so it will be constant. A is area of cross section of rod, so it will be constant. So we're left with Y, that is variable, is equals to restoring force. So for any different expression, first we have to calculate coefficient of displacement. So we have displacement here Y, and coefficient of it is this part. So it will act as a spring constant. Hamza, is it clear?
Yes, sir.
Therefore, spring constant will be rho g A. Next, we have to calculate mass of this particular rod. Let's say this rod having length L, area of cross section of its base is A. So mass of rod will be density of rod into volume, that is area of cross section into length. Now we have both K as well as mass of rod. So according to formula, time period is equals to 2 pi root under m by k. Just substitute their values. So it will be 2 pi root under mass we have sigma AL divided by k rho g A. A and A will cancel out. So we'll get 2 pi root under sigma times L divided by rho times gravity. Hiba, any doubt?
No, sir.
Okay, just write it down. Hiba, done?
Yes, sir.
Next is simple pendulum. From any support, a bob is connected to a string and is being oscillating to and fro, to and fro. Let's say this is length of string theta. Mass of this bob is m. So it must be experiencing a force due to gravity along this direction. So if you break its component, this is m times gravity. So this will be again theta. So component of this mg along this part will be m times g into cos theta. And component of mg along this direction will be mg times sine theta. Let's say displacement from this point to this point is x. So first, which force in this part is responsible to move this bob back to its original position or mean position? Hiba, just tell me, in these different forces, which force is responsible to move this bob back to its initial position? This particular component mg cos theta is acting along this particular string. Since there is no any movement along this particular string, so there will be no impact of this part. Ng sin theta component is acting along this direction, so it will be capable of moving this block towards this direction, that is in the direction of mean position. So we can say mg sin theta will act as a restoring force in this part. Hiba, is it clear?
Yes, sir.
So let me define you for this part assumption. Consider a bob of mass m attached to string of length L is oscillating to and fro so restoring force in this part is mg times sine theta. Since this is restoring in nature, so there will be negative sign with it. For a small angle, sine theta is equivalent to theta. So you may write it as minus of mg sine theta is just theta. Now, according to the relation for theta in terms of calculation of angle in radian, it will be length of arc divided by its radius. Since in this particular segment we have theta and perpendicular to it is x, so it will act as length of arc, and adjacent side is L, so it will act as radius. So theta will be x by L. Now, if you substitute this part in this expression, you'll get mg x by L is equals to restoring force. Hamza, just tell me in this expression, which is variable part? M, G, L, X.
X.
Good. So you may write it as mgx divided by L is equals to restoring force. Now, according to the concept of SHM, coefficient of x, this entire part will act as spring constant. So we can say spring constant is mg divided by L. So time period is equals to 2 pi root under m by k. Just substitute the value of k. So you'll get 2 pi root under m by k, and k we have mg by L. Mass and mass will cancel out. So you'll get T is equals to 2 pi root under L by G. Final expression of time period. Khalid, any doubt?
No, sir.
Okay, just write it down. Hamza, done?
Yes, sir, done.
Now in this last expression, we have T is equals to 2 pi root under L by G. L is length or distance of center of mass of bob or oscillating body from axis of rotation. G is net acceleration of system at that condition. Let me define a problem related to this part. Suppose on a swing, a boy is first standing like this. And second part, let's say time period in this case is T1 and time period in this case is T2. So you'll be asked, what is the relation between time period in these two cases? What will be the relation between T1 and T2? Hiba, any guess? Let me define you how to solve. This individual is acting like any point object or bob, and on its oscillation on this particular swing, we have to define its distance of center of mass from axis of rotation. So this particular individual may have center of mass at this point. So its distance from this axis till this point will be about this one. On this position, center of mass will be at this point. So distance of center of mass from axis of rotation will be about this. Let's say this is L1 and this is L2. So first, what is the relation between L1 and L2? Hamza? Is there any relation between L1 and L2? You will say L2 is greater than L1. Is it clear?
Yes, sir.
And according to the formula, time period is equals to 2 pi root under L by G. So more the length of or more the distance of center of mass, it will have more time period. So we can say in T2 position, time period will be more as compared to T1. Khalid, is it clear?
Yes, sir.
Okay, just write it down. Hiba, done?
Yes, sir.
Next question will be on the basis of acceleration of system. You'll be asked, suppose we have lift. In first case, it is going upward. In second case, it is going downward. And third case, it is in free fall. So in first case, net acceleration of system becomes g plus a. In second case, net acceleration will be g minus a, while free fall, acceleration of body will equals to g, so net acceleration will be 0. So if you substitute these acceleration to the expression of time period, in this case, time period will be 2 pi root under L by g, but it would be net acceleration in this part, so it will be g plus a. In this part, it will be 2 pi root under L by g minus a. And this part, time period will be infinite. Similarly, if you place this simple pendulum at center of Earth, so also at this position, net acceleration will be 0. Similarly, in satellite, which is revolving around planet, so net acceleration in this case will be 0 in this part also. So time period in these conditions will be also infinite. Hamza, any doubt?
No, sir.
So these are different cases of lift problem. Just write it down.
Done, sir.
Okay. Next question will be on the basis of percentage change related to these different terms. According to the formula, we have time period is equals to 2 pi root under L by g. So we may write this part as 2 pi L raised to 1 by 2 and gravity raised to 1 by 2. If you have to calculate percentage change in this part. So delta t divided by t into 100, that is percentage change in time period. 2 pi is constant, gravity is constant, so we're left with just length. So it will be n, or the exponential get multiplied with its coefficient. So it will be delta L divided by L into 100. So this is calculation of percentage change in time period with respect to percentage change in length. But this formula is applicable only in case of if percentage is less than 10%. If change is less than 10%. Now, how to define percentage for more than 10%? So you may write the above expression as p square is equals to 4 pi square L divided by gravity. Khalid, is it clear?
Yes, sir.
Now in this expression, we have two different parts. One is time period and the other is length. So time period having exponential 2 and length having exponential 1. This is similar what we have done in chapter 6 with momentum and kinetic energy. It was p square is equals to 2 times of m into kinetic energy. So this is p square and this is kinetic energy having linear power, just related like this. Hamza, is it clear?
Yes, sir.
So in these type of relation, if L or T is increasing or changing by any amount, let's say if T is changed by X%, so percentage change in length, it will be 1 plus X by 100 squared minus 1 into 100. If it is increasing, then it will be positive, and if it is decreasing, then it will have negative value. Similarly, opposite of it, we may write it as if L is changed by Y%, percentage change in time period will be 1 plus or minus Y by 100 root under minus 1 into 100. This is the same relation what we did in chapter 6 for momentum and kinetic energy. Hiba, any doubt?
No, sir.
Okay, just write it down. Then I'm giving you some problem related to this part. Hamza, done?
Oh, yes, sir, done.
Okay. If length of simple pendulum is changed by 2%, find percentage change in time period. If length of simple pendulum is decreased by 19%, find percentage change in time period. Just use the previous relation according to these two different parts and try to solve. Hamza, just tell me the first answer. Here we have length, which is changing by 2%. And we have to calculate percentage change in time period. So first check whether this percentage is less than 10% or greater than 10%. Hiba?
So less than 10%.
So we have two different formula in this part. The above one for less than 10% and the below one for greater than 10%. So which formula do we use in this part? The above one or the below one? Hamza,
So above 1.
good. So according to this relation, we can say delta t divided by t into 100, that is percentage change in time period, it will be half delta L divided by L into 100. So this is percentage change in time period, and this is percentage change in length. We have given in this part percentage change in length is 2%. So it will become half multiplied by 2, that is 1%. Hamza, is it clear?
Yes, sir.
Similarly, try to find the second part according to the relation. Again, we have percentage change in length, 19%, decreased by. Since this particular term is greater than 10%, so you must use the below one. Just substitute their value and try to find. According to the formula, it will be delta t divided by t into 100. Since this is greater than 10%, so it will be 1 minus y by 100 root under minus 1 multiplied by 100. Just substitute y as 19 and just simplify it.
Sir, is it mod of or bracket?
I've just drawn mod so that its value will be always positive. If you put y is equals to 19, so it will become 1 minus 19 divided by 100 root under minus 1 into 100. So just take LCM to be 100. So 100 minus 19, it will be 81 by 100 root under minus 1 mod into 100. So root of 81 will be 9 and root of 10 will be 100 will be 10. So it will become 9 by 10 minus 1 into 100. Further, taking LCM to be 10, so it will be 9 minus 10 minus of 1 by 100. That's why I've taken mod to this entire part, so that it will become positive. So plus 1 by 10 into 100, so it will be 10%. Hamza, is it clear?
Yes, sir. I got this answer.
Good. This is all about this simple pendulum. Next is spring mass system. Suppose spring having length L, area of cross section A, and elasticity, we may define spring constant as Y A divided by L. So in this part, spring constant depends upon length as inversely proportional to each other. So you'll be asked, what will happen if you break this particular spring or cut down this particular spring into some segment? If you cut this particular segment into, suppose, ratio as 1 is to 2 is to 3. And on the basis of this segment, we have to calculate spring constant of each part with respect to the original one. So first you will do, on the basis of their segment, we may write it as 1x for first segment, 2x for the second part, and 3x for third part. Sum of all these three different segments will equals to actual length of a spring. So x will be L by 6 from this part. Hiba, any doubt? Now we have three different segments. First part is x, so it will be L by 6. Second part is 2x, so it will be L by 3. And third part is 3x, so it will be L by 2. So using the formula, K is equals to YA divided by L, and L we have L by 6. In second part, K is equals to YA divided by L, and L we have L by 2, L by 3. In third part, K is YA divided by L, which is L by 2. This is nothing but K, K, and K. So it will become 6K, 3K, and 2K. So this is how we can calculate spring constant on the basis of different segment of a particular spring. Hiba, any doubt?
No, sir.
Just write it down. Done.
Potential.
Now we have to derive combination of spring. Combination of spring. First is series combination. Let's say one of the spring is this, having its actual length L1 and a spring constant K1 connected to another spring K2 having length L2. And a block is attached to this point. Let's say this is equilibrium position. Now, if you displace this particular system slightly towards right, so first spring got elongated up to this part. Second spring up to this part, so that this block will move to this point. So total extension will be X. In first spring, it will be L1 plus X1 up to this part. In second spring, it will be L2 plus X2 up to this part. So from this part, we can say total displacement from its original to final will be x1 plus x2, since natural length of spring was L1 plus L2. So from this, we can say displacement in both spring is different. Since this spring is massless, so tension for massless string will be equal at each different point. Similarly, force will be same at each different point. So from this, we can say net displacement is x1 plus x2. According to the formula, F is equals to K times of X. So X will be F by K. So it will become F by K equivalent with negative sign. F by K1 and F by K2. F, negative, negative, negative will get cancelled out. So you'll get 1 by K equivalent is equals to 1 by K1 plus 1 by K2. So this is K equivalent in case of series combination. Khalid, any doubt?
No, sir.
Just write it down.
Sir, did you ask something by the way?
No.
I got disconnected. That's why.
Okay. Hamza, done?
The last one. And then sir.
Suppose we have spring like this. Having spring constant 3K, 6K, and mass of this bob is m by 2. Find K equivalent and time period. So in this part, we can say this arrangement is series combination. So use the formula what we have derived in the previous part. Calculate K equivalent and then time period. Hiba, you got any answer?
Doing, sir.
Tell me the formula for this. Since this is series combination, so it will be 1 by K equivalent is equals to 1 by K1 and 1 by K2. Hiba, is it clear?
Yes, sir.
The value of K1 we have in this part. Just tell me.
See?
3K. And similarly for K2, it will be 6K. Take LCM to be 6K. So it will become 2 plus 1, that is 3 by 6K, or just 1 by 2K. Since we have to calculate K equivalent, so just reciprocal it. So K equivalent becomes 2 times of K. Now, time period is 2 pi root under M mass of block, that we have M by 2, and K equivalent 2K. So it will become 2 pi root under m by 4 times of k. Take out 4 from this square root. So it will become 2. So 2 pi divided by 2 root under m by k. 2 and 2 will cancel out. So you're left with just pi root under m by k. Hamza, any doubt?
No, sir.
Khalid, is it clear? Just write it down. Hamza, done?
Yes, sir. Done.
Okay, any doubt up to this part?
No, sir.
Let's stop here for today. We'll continue in next class after it. I will define you parallel combination, then different types of oscillation, that is damped oscillation and damped oscillation. Then we'll start with new chapter, that is wave. Okay. So let's stop here for today.